Hi everyone. In this video, we are going to solve a couple of trigonometric equations and we will see how to find out the general solution as well as the principal solution. We are going to take two examples and I have them on the screen here. So first we are going to solve the first example, which is cosine of 2x plus sine of x is equal to 1. As you can see in this equation, cosine function has 2 times x and sine function has x. So we need to convert them into a form where all the ratios will be either of 2 times x or just x, right? So here the easiest way would be to convert cosine of 2 times x into some function of just x. Now we know that cosine of 2 times x is equal to 2 times cosine squared of x minus 1. Also it is equal to 1 minus 2 times sine squared of x. Since we already have a term of sine of x, I am going to use this expansion right here, which is 1 minus 2 times sine squared of x, and then it will be easy to solve, right? So let's use that expansion. So we can say that cosine of 2x can be written as 1 minus 2 times sine squared of x, plus we already have a sine x is equal to 1, and here we see there is a positive 1 on both sides of the equal sign, so they are going to cancel each other, and then we are going to be left with negative 2 times sine squared of x plus sine of x is equal to 0, and if we multiply both sides by a negative 1, then this will become 2 times sine squared of x minus sine of x is equal to 0. And from here, if we factor them, what is the common factor here? Well, sine of x is a common factor. So if we take a common factor out, sine of x times, on the first term we will be left with 2 times sine of x, and from the second term we are going to be left with just a 1 there. So now we have two factors, and to solve any trigonometric equation there are two tricks. Either we have to convert them into a single trigonometric function on one side and the other side could be any numeric value. The other way is we have to bring everything to the left hand side, make the right hand side 0, and then try to factor on the left hand side. Now here you see we have been able to come up with two factors. Now from here we can say that sine of x equals 0 or 2 times sine of x minus 1 equals 0, and from the first one we can say that x is definitely equal to n times pi. In the first video of the trigonometric equation series, we have seen that when sine of x is equal to 0, then the general solution is x equals n times pi, where n is an integer. Now let's see what we get from the second factor. From the second factor we are going to get sine of x equal to 1/2, positive 1/2, which can be written as sine of 30 degree, that is pi over 6. And then from the second one we can say that the general solution here would be x equals n times pi plus negative 1 raised to the power n times pi over 6. So our general solutions are two of them, right? So we can say x can be n times pi or n times pi plus negative 1 raised to the power n times pi over 6, where n is an integer, of course. Now if we have to find principal solutions, let's see how that looks like. When we say principal solution, that means we are talking about the interval 0 to 2 pi. So x is greater than or equal to 0 and less than 2 pi, or using the interval notation we can say x belongs to the interval 0, 2 pi, where 0 is included in the interval, 2 pi is not included. That's by definition is the principal solution, meaning the value of x within the range of 0 to 2 pi, 2 pi excluded and 0 included. So from x equals n pi, let's use various integral values of n. I am going to use positive integral value because x has to be between 0 to 2 pi. It's a positive angle we are talking about. So I am going to use non-negative integers here. So first I am going to use 0. When n equals 0, x is equal to 0 radian. When n equals 1, x is equal to just pi, 1 times pi. When n equals 2, x would be equal to 2 times pi, but we cannot take that in our answer because x is within the range of 0 to 2 pi excluding 2 pi, of course. So we cannot take 2 pi. So we have to reject this one and we have to take this one and this one. And similarly from the other solution, let's see what value of x we get for different values of n. So from the second solution we have x equals n pi plus negative 1 raised to the power n times pi over 6. And here if we use n equals 0, then x will be just pi over 6. When n is equal to 1, x will be pi minus pi over 6. that is actually 5 times pi over 6, and when n equals 2, x will be equal to 2 pi plus pi over 6, and we have to reject that one because we have to find the answer between 0 to 2 pi, so we have to reject this one and we're going to accept this one and this one. So looks like we have 4 solutions for the principal solution. So we can write the principal solution like this. We can say x belongs to these 4 values. It could be 0, it could be pi over 6, and then 5 pi over 6 and pi. Using the set notation, you can write them in any order, but I thought it would be nice to write them in the ascending order, so I arranged them like this, and that is the principal solution. I hope everything made sense. Next we are going to work on the second example, and our second example is 5 times cosine of x minus cosine of 2 times x is equal to 3. As we can see in this equation, we have only cosine function, but still we have a problem. In the first term we have cosine of x, but in the second term we have cosine of 2 times x. So somehow we have to convert them into a function of just x or maybe a function of 2 times x, right? We cannot have a mix like this. Using the same concept as in the previous example, let's try to convert cosine of 2 times x into a function of cosine of x. We know that cosine of 2 times x is equal to 2 times cosine square of x minus 1. So let's use that identity. So then here we have 5 times cosine of x, we are going to keep that as is, minus cosine of 2x, I am going to write that as 2 times cosine square of x minus 1 is equal to 3. And from here what do we get? We get 5 times cosine of x minus 2 times cosine square of x plus 1 minus 3 is equal to 0. I am bringing the 3 to the left hand side, and from here we have 5 times cosine of x minus 2 times cosine square of x minus 2 equals 0, and if we multiply both sides by a negative 1, then we are going to get positive 2 times cosine square of x. I am just rearranging them little bit, and then negative 5 times cosine of x and positive 2 is equal to 0. Now let's try to factor them on the left hand side. We can say this is 2 times cosine square of x minus, we can expand it as 4 times cosine of x and then minus cosine of x plus 2, all of that is equal to 0. And then from the first two terms we have 2 times cosine of x as the common factor. Then from the first term we are going to be left with just cosine of x, and from the second term we will be left with a 2, and then let's take a minus 1 as the common factor. Then we have cosine of x minus 2, all of that is equal to 0. And from here we have cosine of x minus 2 as the common factor, and then we are going to be left with 2 times cosine of x minus 1, and now we have two nice looking factors. So from here we can say the first factor is equal to 0, which is cosine of x minus 2 is equal to 0, or the second factor is equal to 0, which is 2 times cosine of x minus 1 is equal to 0. Now from the first factor what do we get? We get cosine of x is equal to 2, or from the second factor we would get cosine of x equals positive 1/2, because if you bring the negative 1 to the right hand side, that will become positive 1, and then you divide both sides by 2, so then we get cosine of x equals positive 1/2, and that is actually equal to cosine of 60 degree, which can be written as cosine of pi over 3. Now look at this first factor here, cosine of x equals 2. Now is that ever possible? Actually not, because we know that the highest value of any sine function or cosine function cannot be greater than positive 1. It has to be less than or equal to positive 1. But here we have cosine of x equals 2. So that's not a possible solution. So we have to reject this one. So we are going to reject that. Now how about the other one? Well, the other one is looking nice. We have cosine of x equals cosine of pi over 3. So from here we can say, well, then we get a solution here that x will be equal to 2n pi plus or minus the angle, which is pi over 3. That's the general solution in this case. So in this case we have only one general solution, and that is x equals 2n pi plus or minus pi over 3, and of course n is an integer. Now let's also try to find out the principal solution. Let me write down the general solution here again. We have x equals 2n pi plus or minus pi over 3. For principal solution, we know that x will be between 0 and 2 pi. So let's first try 0 for n. So we are going to try n equals 0. Now when n equals 0, x equals plus or minus pi over 3. For principal solution, we are going to take only the positive angles. So let's consider only the positive angle here. So I am going to write it as positive pi over 3. And now let's use n equals 1. Then what do we get? X will be 2 pi plus or minus pi over 3. So first let me write down the plus pi over 3, and the other value is 2 pi minus pi over 3. Now can we use 2 pi plus pi over 3? No, because for principal solution x has to be less than 2 pi. So we really cannot take this value right here. So we have to reject that. But we can take this one, we can take that one, and if we simplify this, this will be 5 pi over 3. So we can see we have two values of x for the principal solution, and they are pi over 3 and 5 pi over 3. So we can say that x belongs to pi over 3 and 5 pi over 3. So we can finally say that x belongs to a set of two values which are pi over 3 and 5 pi over 3, and that is the principal solution. And the general solution, of course, 2n pi plus or minus pi over 3. I hope it all made sense. Thank you for watching. See you in the next video.